Welcome students, welcome to expert tutorial. So this today's video is the continuation of my previous lecture. So as I stated earlier that Hooke's law is stress by strain is constant, that is within the limit of elasticity the stress is proportional to the strain. So the ratio of stress and strain is constant, and this constant is known as the modulus of elasticity. So there is a limit. So from the Hooke's law, basically we know that there is a limit up to which the body is said to be elastic. So now coming to the graph of this stress and strain. So this is the graph you can see from the picture. So this graph has different parts. So first of all, the initial portion of this graph, that is up to the point A from the point O, you can see that up to this point A from the point O, the graph is, the stress is proportional to the strain and the graph is a straight line. So it indicates that up to this point A, the increase in length is directly proportional to the load or the stress. So Hooke's law is obeyed in this region. Okay. So this point is known as the limit of proportionality. So this is known as the proportional limit or limit of proportionality. So beyond this point A, the graph begins to be curved. So this indicates that on further increasing the load, the increases in length is no longer proportional to the load, but it increases with the increase of the strain. Sorry. So the increase in the length, so there is an increase in the length with the increase of stress, but it is not proportional here. So it is not the proportional here. But however, up to the point B, up to this point B, the elastic property exists. That is, after withdrawing of the deforming forces, it regains its original position. So this point B is known as the elastic limit, and it is called the yield point, elastic limit or the yield point. So beyond this elastic limit B, with increasing load, the length increases very rapidly. So here, basically here, the load increases, the length increases rapidly. Now at this stage C, on removing the load, the body does not return to its original length, but its length is permanently increased. So at this point C, if we removed the deforming forces, it gets an permanent there is a permanently increased length after removal of the external force or the deforming force. So this is the permanent increase in the length. Now on further increasing the load, the length increases still more rapidly, that is this region. So ultimately a point D is reached when the stress takes a minimum possible value. This is known as the breaking stress. Now if we further increase the load, or if we decrease the load after this point, the wire goes on thinning down until it breaks at this point. So the region from this C to D is known as the plastic region, or this particle shows a plastic nature here or plastic behavior here. Okay. So this graph is very important. So I think all of you understand this graph clearly. So thank you everybody.